And she was like, that's so
silhouette on
pretentious.
the
She's never heard anyone say that.
Really?
Yeah.
I always heard that all the time.
Thank you, Sam.
I got called by a kid in my math class.
Are they like a freshman or were they?
Thanks, Vinny.
The man's Vinny?
Yeah, sophomore. I said, what do you mean I can stop calling you?
Oh my gosh, have you all done it?
Not yet.
I just remember the first time math being like, we opened up the tablet.
That's later.
So I think that was they worked with you yeah. Okay, Dad.
That smells good, Oliver.
You want it again?
Yeah. It smells good. I thought that was so fun.
And they're like reused tablets. They don't get a fresh one. It's
Wait, so are they
It's
like
like
spread, like they're like already kind of open?
yes,
Like,
it's one they've been using
Yeah,
for like
I've seen
20
them.
years. And then you go and put it back.
wait, you know that one?
You guys are
that
big
thing of
classes.
skin?
And how many is it?
It's like,
Yes.
it's
Where
like,
it's like moisturizing. Yes.
Oh, like the
okay.
face?
that's what I.
You got the Uber that's still the
Well, what happened?
I missed my
How
bus
many
by
seconds
1
in?
minute. And then my grandma so
You walked.
now I got an Uber.
Is it that?
Yeah.
Take Uber is
I thought it'd be more
special.
special. The dude was actually so
That's
chill.
one of the things I got.
I like came to a late
So
too.
they're signing up to drive
I think I'm
kids.
actually.
They can get like pedophiles.
But I think the whole point is that it's really like hard. Because yeah, just Uber and Uber
He
drive.
said it was his first time driving someone's kid.
I missed my foot. Apparently there's like a hard F4Q5.
Like, I think the point is that they're really careful. I mean, like,
And its calculator
I
app.
did it.
I mean, they're taking out the
Where is the interval? 0 to pi is the secant line parallel to the tangent line for y equals to sine x.
So bad for 5 minutes.
That's
so do you ever heard of people like renting chairs? Like,
Was over what?
it's literally called the
That's
mean.
nuisance.
Yeah, you
At least, okay, wait, why is it a pumpkin rented table? It's a pumpkin pie.
you put.
Uh,
You like did it with like
Like the CO.
oh yeah.
Circumference over
Well, like how else do you think that let me send you.
I don't know, you
So we're
buy
having
a table
friends
and sit.
sitting, and then
Oh, you go up and like
yeah, and she's like, okay, I don't have 25. And she's
shadow boxing. It's reverse shadow boxing.
yeah.
And that's just appalling.
That's crazy.
We either
I feel like I'd make everyone bring a chair.
She was like, you're just expensive, you don't get a chair. And I was like,
A bunch of people are upset because whooping cough is going around. And
Watch everyone go down
Roy
the
isn't
slide.
German, so I thought whooping cough was like a German word. The whooping cough. Is going around. Well, this,
Wait, can you
I'm not
refund it?
vaccinated, so.
Can you refund the chair?
Well, I've had a headache for like the past 2 days
I
and
feel like no.
like
Well, yeah,
my throat
it's
is
like
dry.
the chair, like.
We're so hypochondriac. We're so what? Hypochondriac. Oh, what is that? When you think you have, when you think you're sick, when you're. Oh. I don't know. I remember who it was. We were like a hunting road but if you die, you didn't come back. It kind of ruins the point of a road But it was specifically, I don't know why. Anyway, and it
Yeah, like
one of the dungeon, like, treasure chest areas or like reward areas, we like escaped, but then we got to like the sidewalk, and I was trying to get to the sidewalk, and then the car like swerved to avoid me and hit one of the people on the sidewalk, and then turned into a cupcake, and then it ran to the evil bad guy, looking at the cupcake from the
Jason, I don't want you to refill my
Such a
Because they say like I feel like I've never.
Anyone?
Yeah, me too.
Crazy. I gave up on that first go.
My brother brought me a separate email.
I still put one on there.
Close contact? Alright. Nah.
No, but my mom called the pediatrician.
You're gonna spread it out.
6 feet.
I gotta get back to my desk.
So like, what if no
I gotta go.
one-
You're
Oliver,
in
have you ever heard of renting chairs?
renting chairs.
See,
This! No one's ever heard of that.
You get
What
put
are you
on
talking about?
recycling bin and he doesn't someone threw up there like and there's no trash bag.
Why would you rent chairs?
That's
That's what I'm saying. I didn't, why? You know what I did? I went to Tick's house and I grabbed chairs for them. I didn't rent them, I just took them. Exactly. You don't need to rent them, you just need to find someone chairs. Wait, no, for a wedding though. But like,
Exactly.
for birthday last year, they rented tables, chairs, rented them, and they rented plates and glasses. You should have sent me up. I could have found you some folding chairs and some folding tables. We would have been good. We would have been good with the folding. You would have saved money.
I feel like the
Yeah.
recycling bins at that.
Hey, if you did that, you could have gone like
It's really
4
not.
birthday
It's
gifts.
really not recycling, not like this.
Hey, free is cheaper than money.
Exactly.
You could invest that money and then you like think about all the money you would have paid with that. Yeah, it lost the profit. It's not cheap. It's smart.
You clearly have to do my closet.
Y'all gotta lock in on that.
Also, Laura has.
Yes, she does. Don't go
So
to
bad.
You can't.
That's a plus blood type of
I don't think that was on the test. That was on the study guide was on the test.
My brother got an email.
Your brother.
Been in close contact. But I know this is
I know. The quiz is not.
Yes, pop it. Oh my god.
I'm going back to the.
Don't worry about it. Take it.
Whooping cough.
Wait, I thought you just said that.
And then like, not spending time What did you say?
We have a test before the.
Have you taken a physics test?
Wait, when do we have a quiz? We have a quiz before the next.
No, I already took it. It was easy.
That's fine.
It was light. That was
Hey, did y'all also think you had Okay,
20 minutes.
I got 6.
20 minutes for tape.
I survived. I did it.
As long as I know I can.
Or yeah, I agree. Like, kind of just like talk about bubble science.
All right, take a seat, please.
No, I think it's like the very first one where it's true.
So I thought the quiz was today, so I studied everything on it.
And the thing on the study guide was.
Because I looked on the slide. Oh my god, quiz. Like I saw the quiz and I was like, okay, I have a quiz.
Buzz.
I don't know.
Did you get the
So
name?
I was so shocked. I was like,
Is it just like first and second?
Everyone else did.
Good morning, FHS. This is Julian Young, and I'm representing 11th grade. Please join me in a minute of silence.
Settle down.
Please stand as you're able for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, and with liberty and justice for all. Thank you.
Okay, I guess that's it. All right, good morning, guys. So I need to give you, obviously we have a limited number of days before we will be out, not just for Thanksgiving break, but winter break. So just a heads up with the handful of days that we have left. So once again, we do have the final exam in fall. One second. Is it important to ask right now?
No.
Okay. We do have a final exam in fall. So part of what we need to do in our last few days is do some review, look back at some of the things we've talked about from previously in the semester. We do not allow exemptions on the fall final exam, but typically we don't make you do a spring final exam because you take the AP exam. So that's on the agenda. We do a couple of the smaller, easier introduction lessons to the next unit. So we don't have time to do an entire full College Board unit with the time we have before Thanksgiving break and between Thanksgiving break and winter break. But we do have time to start a couple of those. And that's important because Unit 6, the one that the first unit we will have a test over when we come back in January, is probably the hardest of the year. So doing a couple of the topics before winter break just kind of spreads that information out and makes it a little bit easier. Now, the good news is, and again, this is a long time from now, the 7th unit is probably the easiest of the year, so that kind of helps balance it out. But in the short term, in January, that will be a problem. So one of the things we'll do is look ahead to a couple of those things. All right, and then finally, we've got a few other topics that we had just skipped at some point because they were not super pressing at the time. So one of those is using tangent lines to do approximations. So we've talked about tangent lines before, but we haven't formally practiced or talked about how to use those to do estimations. So we'll spend about a day on that. There's a process called L'Hopital's rule that makes limits, most limit questions very easy. So we'll definitely do that before the semester exam, because the semester exam will have a couple limit questions on it, and there's a good chance that L'Hopital's rule could make those easier for you. I didn't show you L'Hopital's rule the first few weeks of school because you have to know how to do the derivative. So that's another topic that we had skipped that we need to kind of go back and make sure we have done. And finally, mean value theorem. So this is the one we're going to spend all class period on today. And then down there at the bottom for homework, you can see it says finish 54. That's going to be a little bit too much, so I won't ask you to be done with assignment 54, but we'll get a little more than halfway through it. So this is the last of the three. Well, first off, mean value theorem technically fit in our last unit. Last year, though, I decided to take it off of the test you just took, just because I feel like there was already plenty of information on the last test for you to study and learn. So mean value theorem was really supposed to be in that unit, but I took it off to try to help narrow your focus a little bit. But mean value theorem is super important. So we will have a quiz that goes in as a major grade, and that will be the last day before Thanksgiving break. The good news is it's just one topic, so that makes it very precise to study for. And it will go in as a 10-point major grade. So your last three tests have been 40, 40, and 50. So, you know, compared to a test, it's not a lot, but I do need to give you major points. I need to make sure that this is one that you can do. This is also the last three of the big theorems. So week 1, we talked about intermediate value theorem. Last unit, we talked about extreme value theorem. And then now we've got mean value theorem. Okay, so Jacob, what was your non-pressing question before we talk?
Well, I just heard you might be not feeling too well, and I was scared that you might have the whooping cough.
No, I've not coughed yet today. I'm good.
Okay, that's good.
Thank you. I appreciate your concern.
Oh, yeah. You coughed today, Jacob? A little bit. I heard some of those rooms. Yeah, I did.
Okay, guys, back on track, please. I'm not going to take silly questions like that if y'all get too derailed here. Okay, so mean value theorem. When we say mean value theorem, obviously we're not talking about the not nice mean. We're talking about the math mean, which is average. And we are in the calculus portion where we do derivative stuff. So mean value theorem has something to do with average and something to do with derivatives. So before I tell you what the mean value theorem says, there is 2 conditions that have to be true. On the bottom of these notes, I will give you an example to show you why those things have to be true. But it has to be if it's continuous from A to B, including A and B, and differentiable meaning you can take the derivative from a to b open interval, so it doesn't have to include a, it doesn't have to include b, but it has to include everything in between them. Mean value theorem says that there is some x value c between x values a and b such that the instantaneous rate of change, which we know as derivative gives you slope at an instant, the rate of change at an instant is derivative, has to be equal to the average rate of change, which is really just a slope formula, at least once. Sometimes more than once, but mean value theorem says if this is true and this is true, there has to be at least one time when x equals c, when the derivative equals the slope, when the instantaneous rate of change equals the average rate of change. So first, let me just kind of dive into an example so you can see like what your work would look like, and then we'll look at a couple of pictures so that you have a visual of what we're finding. Okay, so mean value theorem questions most of the time are like this. Here's a function between -2 and 2. Find the value c that's guaranteed by the mean value theorem. So you need to be thinking, well, can I even use the mean value theorem? Is it continuous? Yes, I know it's continuous because this is a polynomial. Polynomials are always continuous. What would make it not continuous is if you had x's in the denominator, or perhaps a square root. If you had the square root of a negative number, that would not show up on a graph, so that would not be continuous. Yes.
If, like you just said, if it was like a square root of a negative number, but the interval was like 2 positive numbers, would it still be continuous?
Okay, so in this case, or even this, like if you tried to plug this into the function, that's fine because the square root of 0 is still 0. That exists. If this was like this would be a problem. Or, no, this would not be a problem. That would be a problem because numbers less than 1, which is some of the numbers I need, would give me imaginary solutions, and imaginary solutions wouldn't show up on a graph. So that's not going to happen very often, but it's one of those things that if you guys don't make a habit out of checking it, then there's going to be questions you miss because of that. Polynomial, always continuous. There's no division by 0, there's no square roots of negative. We'll see a square root or 2 on this page before we're done. Now, differentiable means that you can take the derivative at any x value, but this has had to be continuous on the closed interval, has to be differentiable on the open interval. So, if you don't know, can I plug in all numbers bigger than -2 and less than 2 into the derivative? One easy way to do that is to just go ahead and find the derivative. We're going to need it in a second anyway. And then basically ask yourself the same thing. It's not going to be differentiable if there's a value of x that gives the derivative to be undefined. There's no x's in the denominators. There's no potential of square rooting negative numbers. It is differentiable the whole time. Okay, so if the conditions are met, then what you need, and this is what you're going to do on 90% of these questions, you're going to set the instantaneous rate of change derivative equal to the average rate of change slope formula. Instantaneous rate of change derivative equals average rate of change slope formula. Every time, derivative equals slope formula, derivative equals slope formula. So honestly, there's 3 places that these questions can change in difficulty. Sometimes the derivative can be harder. This one was nice because it was just power rule, but sometimes we got to do product rule or chain rule or whatever. The arithmetic and finding the slope formula can be a little challenging without a calculator. You need to be careful. And please double check my work here because I'm doing this quickly. That would be, is that -6? Tell me if you don't get -6 there. Okay, so we get -8/4. I do remember this from yesterday. So the slope formula tells me that the slope is -2. So what mean value theorem says is if the conditions are met, there has to be at least one, maybe more, but at least one time where this instantaneous rate of change derivative has to equal the average rate of change slope. Now, if you're asked to find that value of c, you're trying to find the x value that makes this true. So then you also have to solve this equation. So that's the third place these can be harder. Sometimes the derivative could be harder, sometimes the arithmetic in the slope formula could be harder, and then sometimes the solving the equation can be a little more complicated. This one's not too bad because we could just subtract 6 from both sides, divide both sides by -6, and then take the square root. And what did I leave off? Very good, plus or minus. Square root both sides, don't forget plus or minus. Now, if one of these answers was 10, that means that when x equals 10, the instantaneous rate of change is equal to the average rate of change. But again, keep in mind, we only care about values between -2 and 2. So actually, if we had had an answer of 2 or -2, you wouldn't even count those. You don't get to count the endpoints. It's some weird quirk of the definition. And if I got answers outside of these, I wouldn't want to report those either. I want to report numbers that made this true that's between those, and both of these are between those. So I need you to see what we are finding visually, because I think it helps you understand what the algebra is finding for us. So I am going to graph it on my screen, and then I'll share the graph with you. Is that plus 6x minus 2? Is that correct? Okay, so here is the function we just worked with, but that said we are going to restrict our domain to -2 to 2. So I'm going to ask my calculator, only show me x values from -2 to 2, so I can kind of focus in on the parts of the question we were interested in. Hold on one sec. There we go. Okay, so what we did on the right side of your paper is we used the slope formula. We said if you start at this point and end at this point, subtracting the y values computes the rise, subtracting the run values, or the x values calculates the run. This is what we found using the slope formula. And using the slope formula, we said that the slope of this was
-2.
Okay, and notice this is going down, so the fact that that's negative is a good sign. Okay, then we took the derivative, which represents the slope at any x value, and we basically tried to figure out when is the slope, the instantaneous slope, also -2. And we got the square root of 4/3, which is like 1.1. So about 1.1 at that instant, the slope is the same as this slope. And at negative square root of 4/3, which is about -1.1, at that instant, they were equal as well. So you're trying to figure out over the long run, if this is the average rate of change, when, at what instances, if more than one, but at least one, where these are the exact same value. And that has to happen at least once. Happened twice there. Okay, then let me say the same thing here with this visual. This way you have one on your paper. So, exact same idea. Here's a function in blue. It's continuous and differentiable. By the way, how do I know this is differentiable? Well, being differentiable implies it's continuous, but being continuous does not imply it's differentiable. You remember from a visual what type of values you can't take the derivative at? Remember the sharp stuff, the cusp? You can't take a derivative at a cusp. That's how I know that this is differentiable. There's no sharp turns. So what they did is they said from A to B, we'll use the slope formula to figure out the average, which is where it gets the name mean value theorem. And all I need to know is the start and the end, and on average, how fast does it have to go up? And then mean value theorem says, well, if it's continuous and differentiable, there has to be an instant that has the same slope. We call that instant x equals c, and at that instant, this slope has to be equal to this slope. The average rate of change has to equal the instantaneous rate of change at least once. There's no way for you to draw a continuous differentiable graph where the average rate of change doesn't equal the instantaneous rate of change at least once. Okay, so next up on the bottom here, let's make some counterexamples to hopefully help you remember that it has to be continuous and differentiable. So you're welcome to make up a different example, but I'm just going to make up a really easy one. And I'm going to draw something that is not continuous so that you can see that mean value theorem does not hold up. So I'm going to pick something easy where the average rate of change is 0, like this. And then I'm going to draw something that's not continuous. It's got some sort of break in the graph, even if it's just for an instant. So mean value theorem doesn't work here because the continuous part of the definition is not being met, and you can see that from this example. The average rate of change is 0. Again, I'm picking something easy. And the instantaneous rates of change are either something positive or something negative, but never 0. Because it got to skip these values, there's no guarantee that it ever turned back around. It skipped there. Doing almost the exact same picture for differentiable. So this time I will draw one that's continuous, but not differentiable. I'm drawing a cusp. And then same idea. I tried to make these be the same so you can see the average rate of change is 0. And then you can see there's never an instant where the slope is 0. The slope is either this positive value, the same thing each time, or this negative value, but it's never 0. It's not 0 here at the top. Your slope can't go from being positive to negative at an instant like that. That's why the derivative doesn't exist. So there's no time when the instantaneous rate of change would have to equal the average rate of change. So mean value theorem doesn't work on that either. Again, now I don't know if that helps. You remember those two conditions, but you need to know those, so hopefully it helps a little bit. Okay, I've got 2 more examples on the next page that I'm going to walk you through to show you the process a little bit more in detail. And then on the bottom, I've got an old AP multiple choice question that I'd like you to try once we get to it. So the next 2 questions are technically called Rolle's theorem, which sounds like I'm trying to show you something new, but I'm not. You do not have to know the name Rolle's theorem at all. Your AP exam will not say anything about Rolle's theorem. But if you like to do math contest, there's a good chance you'll see the name Rolle's theorem sometime, and maybe in a later math course someday you may hear the name Rolle's theorem. Rolle's theorem is really just mean value theorem, but it's a very specific case when mean value theorem has an average rate of change. I just put ROC for rate of change of 0. So again, if you can do mean value theorem, you automatically know Rolle's theorem, because Rolle's theorem is just a very small subset of that. Okay, so I'm going to pretend like this doesn't say anything about Rolle's theorem. I'm going to just pretend like this is mean value theorem, but Each of these, the average rate of change will be 0. That's what makes it Rolle's theorem. Okay, find all the numbers C guaranteed by Rolle's theorem. Check the conditions for Rolle's theorem, or mean value theorem, same thing. So first off, one condition is it needs to be continuous from 0 to 4, including the endpoints. It's a polynomial, so that's a done deal. Polynomials are always continuous. It also needs to be differentiable on the open interval. And if you aren't sure, just go ahead and take the derivative real quick. And then you can see if there's any numbers that are imaginary or give you division by 0. In this case, no. So it is differentiable between 0 and 4. And so now I know mean value theorem is going to work. Mean value theorem guarantees there's at least one x value that the instantaneous rate of change derivative equals the average rate of change slope. Okay, and the average rate of change, we get 0. And again, technically, because this is 0, this is why it's called the Rolle's theorem case. And add 4, divide by 2. X equals 2 is when that occurs. What is the window, 0 to 4 on this one? Is that what it says? Okay. All right. So once again, I want to graph it to visualize and show you what we just did. We just figured out here's 0 to 4 of this last function. So on the right side of our work, we used the slope formula to tell us the average rate of change was 0. The left side of our work, we found the derivative, and we tried to figure out when does the derivative, the instantaneous rate of change, equal the average rate of change. So I can see right here, here's the time where the slope is also 0, and from our algebra, we figured out that that happens right here at x equals 2. So that's what we just did on our paper. We're figuring out when those slopes have to be the same. Mean value theorem tells us that they do have to be the same, but typically we have to go out and find that. Okay, so one more time. So polynomial, I know it's continuous. If I take the derivative, it's also continuous. So it's certainly continuous between 0 and 2 and differentiable from 0 to 2. So I'm not worried about that. Okay, so when does the derivative equal the slope formula? So if you plug in 2, you get a number. You plug in 0, you get a number. Subtract those, you get 0 over 2, which is 0. I'm cheating a little bit because I know that comes out to be 0. But you could plug that into the slope formula, and then you have to solve this to figure out when it happens. If you're asked to find those values of C. C is the term we use to describe the x values that are guaranteed by this. So how do you solve a quadratic?
Quadratic formula?
Okay, we could. Is that your favorite?
No.
Okay, what would you hope is going to work instead? Okay, more often than not, factoring. Now, one of my classes, I won't say who, it was not y'all, but one of my classes we got into a factoring discussion. I'm not convinced y'all did not learn how to factor with guess and check. Y'all like did the A times C process. Yeah. You were told to do the process every single time and not do guess and check?
What is guess and check?
Guess and check is where you like guess 3x times x is probably what I need for 3x squared. This times this needs to be 2, so I could guess 2 or negative 2 and 1. And then the check is you FOIL it and see if it also gives you a minus 6x. If it does, you factored it right, and if it didn't, you tried to make an adjustment. What? I'm sorry?
Never mind. You wanted to stick to the basics, but if we stick to the basics,
Oh.
we want to be able to solve the problem. So, like.
Well, let's work on getting to class on time first.
Family emergency.
Okay, so the bad news is this one does not factor. So my 7th period groaned about this, but quadratic formula in the grand scheme of your math career should not be that intimidating to you. Opposite of B, I'm going to do this super slow so you can see it's not as bad as y'all make it out to be. Opposite of B plus or minus square root B squared minus 4 times A times C all over 2 times A. Could do the arithmetic under the radical. Occasionally you get a radical that simplifies, and then occasionally you can simplify your fraction. I could divide all of these by 2, and there's your 2 answers. Now, technically, I wouldn't keep one or both of those if they're not between 0 and 2, and I don't know what those, I checked the decimals yesterday. If you put that in your calculator and check the decimals, both of those are between 0 and 2, so you would keep both. But not necessarily. If 3 plus the square root of 3 over 3 was bigger than 2, you would not say that's one of your answers. If 3 minus the square root of 3 over 3 was less than 0, you wouldn't want to keep that as your answer. So you'd need a calculator to see the decimal there. Any questions about quadratic formula? Okay, so I've got 2 more things, and then I want you to start trying some of this on the circuit. So the first is I would like you to take a moment to read through this multiple choice question. It's an old question. It's from a AP Calculus BC exam, but the BC exam has a lot of AB material, so you obviously don't need to know Cal BC to be able to do this, or I wouldn't have you try it. But read the question, think about what they're asking you to do, and then see which one of those 5 choices you think has to be true. I'll also add, before I give you an extra minute here, the 4 wrong answers are all wrong for the same reason. So on one hand, I feel like you have a bit of a cheat to this answer. What do you think the answer is?
E.
E. And the cheat is that this is, it's all but saying mean value theorem in this question. But notice it doesn't say anything about mean value theorem. It doesn't give you any hint to think about that. But mean value theorem was a possibility because they told you it's continuous and differentiable. So that's how you should have known it was fair game. And then this says there exists a C somewhere between 0 and 4 such that the instantaneous rate of change equals 0. Is it always supposed to be equal to 0? It's supposed to be equal to the slope formula. So why is this still correct then if that says 0?
The slope formula would be 0 since they both have the same y-value.
Right. Your rise is 0. So that's why that's correct. What is wrong about all 4 of the other options?
Can't know for sure.
I can't be sure for sure about what.
Or you can't be sure that like there's, that the graph dips below, y equals 2 or.
What do you mean? I can see that the smallest y value is 2 though.
But it could go like more, couldn't it?
Like the value of like 0.5, it can still.
There you go. So you know the value at 0, 1, 2, 3, and 4, but this is a continuous function. There's lots of points between 0 and 1, and lots of points between 1 and 2. So it might dip down to negative 10 million and then just jump back out. Up. You have no idea that 2 is the minimum. 2 is the minimum that you see, but you don't see all of this stuff in between those points. Likewise, you don't know the max is 4. Likewise, you don't know the y value is always positive. Likewise, you don't always know that the slope is negative from 2 to 4. It looks like it's going down, 4, 3, 2, but it could be going up temporarily between 2 and 3 that you can't see. So that's pretty common with table questions. You don't know what's going on between those values, and so you shouldn't be making assumptions that they're not maxes or mins or anything else in there. Okay, you guys okay with that question? Okay, before we go on to the circuit, just for something a little bit different here, I put one of my daily puzzles on the smart board over there when you came in, and if you have not read it, I would like you to read that and see what you think. See if you have any opinions, math opinions. Okay, again, my eyes are old. What's the speed limit? 35? Okay. Okay, so you're driving 35 miles per hour. The first cop clocks you at, how fast are you going? Okay, so they see you doing the speed limit, 35 miles per hour. And then you drive, I don't know, for a while, 1.2 miles or something. I think that's right. And then the second cop sees you and sees you doing 30 miles per hour. Is that right? I'm going off memory. So the speed limit's 35. The first cop sees you doing 35. The second cop sees you doing 30. How are they going to give you a speeding ticket?
They could see that, they could like find how long it would take for you to go between the 2 points, like the time. So if you get there quicker.
So let's see, you went 1.2 miles, and how long did that take?
90 seconds.
90 seconds, so that's 1.5 minutes. So
0.025.
wait, hold on. 1.5 minutes, is that what you said?
Yep.
Okay. So I could change the units. 60 minutes is the same as 1 hour. So 1.2 times 60 divided by 1.5 tells me that his average speed was 48. Is that what you were going for? I know you didn't say 48, but okay, so what? Your average speed's 48. The cop didn't see you doing 48.
If your average is 48, then you
Exactly.
have to have been going.
Mean value theorem, you're still getting the ticket. If your average speed is 48 miles per hour, you've got two options. Either you're doing exactly 48 miles per hour the entire time, meaning you broke the speed limit, or sometimes you go lower than 48 miles per hour. But if your average is 48, if sometimes you're going less than 48, sometimes it's got to be more than 48. Either way, they can prove, now they're not going to say mean value theorem in court, but this isn't necessarily like calculus only concept. It's, if they know your average is 48, there's at least one instance you're going at least 48. Yes, why not?
Don't do this.
I'm sure, yes. I don't know how common it is. Now, I would tell you that a situation where I'm sure it's common every single day is like, people that drive like diesel trucks. They have to keep the logs very detailed to make sure that they're not like driving 22 hours a day and they're not being dangerous. You think they don't log when they start and when they end and see what their average speed was to know if they're driving 100 miles per hour or not? They absolutely are looking into that stuff. Now, it may not be the cops, it's the company, but they can still figure out that you were cheating the system. So anyway, I don't know how common that is, but a cop could certainly give you a ticket, and that is certainly provable. So a nice real world example of that. Okay, so if you would, please start on the first few circuit questions. So again, this is where you're practicing what I did for you on the notes. Most of the questions are going to be, make sure the conditions are met, take the derivative, set it equal to the slope formula, and solve. Take the derivative, find the slope with the slope formula, set them equal, and solve. Every single time. That's going to be the process. Maybe not every question, but very, very.
Tissues in the classrooms. I don't want to form a tissue.
You think the test would
Like other things are
Mr. Counselor?
Yes,
If I started the test now, do you think I'd be able to finish it through advisory?
that's not possible.
It's not?
Mm-mm.
So you want me to just do MCQ today, FRQ tomorrow?
I'm going to have you do a few multiple choice and an FRQ today.
Okay.
I'm not-
Multiple FRQs?
I don't do it during class time though, because then you're just falling behind on something else. So,
How far am I supposed to get in this?
question 10.
Okay.
That should be about 6 in class and a couple for homework. So sure, if you get to all 10 in class, then I'll let you start early, but
If I get to 6?
10.
I just want to see if I can get it done today, so I don't have to do it tomorrow.
Again, don't forget that before Thanksgiving, we will have a short quiz, I don't know, probably 5 questions, and it's gonna be this one topic. So you really need to be approaching these questions as, I missed question 1, here was my mistake. Learn from your mistake so you don't make that same mistake on question 2. That quiz is not next class, by the way. I'm gonna give you some more time, but honestly, if you want to go even further than I ask you to on the circuit, that would help prepare you even sooner, but.
I'm volunteering.
Oh, did you get stuck on this?
Do you have tissues?
Sorry, I've been asking for more tissues
No, it's
for
okay.
months.
So do you just like go into the bathroom and just like yank the paper out?
Sometimes the custodian likes to refill them, and so like if there's like,
So you just like smash them off the top?
yeah, they leave it on top. You want there to be no tissue in here at all?
No, I imagine you like sneaking around to the bathroom.
Hey, did you guys get
I'm gonna go blow my nose in the hallway. Go just blow it. No, I have a lot of snot in my nose.
question?
Your head? I don't know.
No, one question about you.
Maybe in like 30 seconds.
That's a scary.
I know I have the work for you to check your process and stuff on the class website, but we'll also over time slowly share the answers up on the board. So I think everybody should be done with number 1. If you didn't get -3/2, you should have me come over and look at your work so I can help correct it before you do a bunch of these and leave and have to figure it out on your own. So.
I got an email. Sophia. It's from my counselor.
Hey, when did you get to that one?
Hey, I love her. She's my favorite. Thank you so much. I want to send her a photo of me with
It'll be on the class recording class, so I have to finish it. Get it to you. Yesterday, first period, and seventh period, this would now, so you can watch one of those. It would be the same thing.
Is it? What? Is this positive or negative square root of 3? How is this hard for you? Oh, that's a slope. Okay, I got it. Let's see what I did before. You know what else?
I'm literally looking at
I also got some question for point. Because I did. How long is it for a tart?
Probably like.
I did ask
Okay, the answer to number 2 is now on the board. Again, I'm trying to be behind you a bit, so if you didn't get that for number 2, you need to let me help you.
We got a problem. We have to do plus or minus it. Wait, it's question mark?
See if it's continuous. It is continuous. But it's a polynomial. But there's an imaginary number here.
You were 27.
What? This
I
would
got
be
a
the
nice
square root of
picture.
-1. Wearing
Well, that's the problem I got.
Wait, no it's not, no it's not. No, because it's negative. It's negative. Never mind. Never mind.
Because I did it on the virtual, so that's why I did it.
It is continuous.
But you are right, I am literally telling you there is a root of the negative number.
Okay, I shared my answer to number 3 on the board also.
Okay, I got 1.
So this is negative 60.
Can I help?
Yeah, you.
Okay.
Okay, so I get this.
Hold on.
Wait. Oh, it's not 9, it's 27. That's
Yeah,
what
you multiplied 9.
This is really humbling. It's like, why am I getting mad? Yeah, this is like sad.
So negative 64 is plus 64 minus the plus, yeah, minus 12.
The stuff I got was.
Oh, you got my, isn't it plus 4?
Wait, is it negative? Wait, oh wait, no, it is negative. Wait, I was right, and I just
The one that's full, it should be,
I just
is
deleted the
really old,
negative
and I
at
have to
some
like
point.
stretch it up and wrap it around my
So
phone book
zero.
and then like
What?
kick it around a certain way to charge it.
I said it's negative, or
It's so,
I made a mistake, but it didn't have anything to do with what you were saying.
What do you mean?
my phone charger.
Why is it minus 4?
Oh wait, cause that's negative 4, okay, so this is negative 64, and that's the negative in front times it, so 64.
And then 64 minus 12 is 48.
And then this is a minus sign, so that
Oh.
Do you like some potion? Yes, thank you. That's also
plus or minus root 5. Where are you?
You actually.
Am I still wrong?
You can't, you aren't the math problem.
I'm getting 9 again. So if you were to Three.
That's
27.
Oh, I got 12.
Plus 9. Plus. That's from the.
Dr. Munster.
Yeah.
Dr. Munster. From my
You're the real Dr. Munster.
Oh, this house in front of very well written. It's just grammatical.
It's like nasal stuff.
Wait, I also got X vertical.
This is negative.
You must be locked in. So I was over.
Yeah, I was taking very interesting to Jerusalem.
Wait.
Yeah, that's okay.
There's some issue with the
One of the weird decimals is
No,
root
like,
5.
you have to start.
But I don't have any how. Wait, oh, was that, no, but that would be on the inner. What?
That's weird. No, I was right here with it.
Wait, what did you get from number?
You still didn't get it, so.
I got plus or minus 0.5. Yeah, and I think it is just one of the answers that's a weird decimal.
That's not me.
It's really far away. I was right. Why did I even give it back to you? I could have just done it myself. When did you, let's say 0.236.
Oh, look, he's there.
That's not it. When did you take it out?
Wait, what if the answer is E minus 1? That's equal to E minus 1.
Notepads. Yeah,
That was so funny. Was this the square root of 3? Well, no, we've already done that one.
Trust me, Jacob.
What? You've already done the.
More professional.
Wait, what? No, I was putting it back.
Oh, that one.
I don't think my folder has it.
It might be the meat volume is all slices.
Well, but it is. Wait, no, look at, okay, and that isn't greater than 4, right?
differentiability doesn't have to include.
If it randomly gusts there,
Is 2.23.
Jacob. Am I supposed to be
Gus,
We had to have made it.
will die if it's I'm waiting for it to move. I need to open up the.
Maybe it's not.
I wonder if this.
Maybe we both got this one. Okay, wait, so,
Well, I got that it was not continuous. So.
Yeah. Yeah, so what you can do is, so this is over 1, to make that divided by 1. And then you multiply both sides by 2 square root plus 5.
I don't know.
Yeah, you multiply both, so.
Okay, I shared my answer to number 4 so that you can quickly see if it's right and know to keep going on or ask for help.
Like just over 1, so like just like, because what you're trying to do is you want to do
You guys get nice or negative?
so multiply both sides by this
Wait,
one.
is that
That's
plus
31. What? By that. I guess, wait. I guess it
wait, it's not 48, what do we do?
It's 56. I trusted you, Zach. I trusted that it was 48.
Okay, so that's negative.
Like pens and yeah, those are my that's the best stationery.
So it'd be negative 104. 104 divided by 8
Okay, I really
is
need to
negative
go
6. Well, that was not right. That was.
Let me double check though. 'Cause I
Actually,
just-
last time I trusted you, you were wrong. Is it negative 13?
Yes.
Oh, wait, yeah.
Yes.
It does cancel out.
Let me double check. Okay, you're right, Zach. You're right. You got my trust. You got your trust.
Usually
You
if
got
it's
your trust.
Okay, so if we want to solve this,
Would you multiply this term by 2 roots of x plus 5 over 2 roots of x plus 5?
you don't even have to do that. That would work.
Wait, that's literally
So if,
the answer.
so yes, if you want to make these have a common
That's
denominator,
crazy.
you can squeeze these together and
What
make
is
fractions.
it?
that is good for a lot of students because the fraction.
Oh, okay. I just couldn't find.
So if you do that, you can just set the numerator to 0. But in this case, I think the problem that you have with this equation is that it's got fractions in it. But you can fix that by, if you multiply this by 2 square root of x plus 3 so that that cancels. That's okay to do as long as you multiply everything by 2 square root of x plus 3. Because then it's like you're multiplying both sides by the same thing. So, if you multiply this by 2 square root of x plus 3, it's still 0. You multiply this by 2 square root of x plus 3, it's just x. And then you multiply this by 2 square root of x plus, or I'm saying x plus 3, I'm sorry, x plus 5. You get 2 times x plus 5, or 2x plus 10. So in the end, you end up with 2x plus 10 plus x equals 0, and then you can just solve that. So whatever way you think is easier.
Mr. Johnson, where did I go wrong?
You forgot a chain rule here. You did times the 2, so that makes that a 4. And then in that part, I don't. Well, I got 3/4.
I went through it pretty fast.
No. Wait, hold on. I got 4 or 1.
Yeah,
I'm sorry,
I got 1.
I got 1.
That 4 might be the difference though, because
When I was looking at multiplying both sides by 3/4, so that makes sense.
oh, they do an exact amount. So I think
I need your calculator to get it within 3 decimals places.
What else good? 12 is 0.
yeah.
Honestly, I didn't even use a calculator until I changed.
Actually, no, I was thinking back, I know.
Like this fraction into a decimal.
You just solved it from here.
Yeah. I think you're both on the same step there, so you still don't have to do it anymore. So I'm just saying you could divide both sides by 4, you can multiply both sides by 3. You could basically just cross
This one
multiply
I got,
here.
it's not continuous.
Just divide by 3, cube both sides, add 3 to both sides. So
Okay.
you just do your normal solving stuff.
Okay.
If you cross
Alright,
multiply.
first continuous, 0, 0.
What's the
You
difference?
guys choose 0? Wait, you're right. Wait, actually might not be. Hold on.
If you plug in -5,
You're right, it's 0.
Oh wait, you multiply by 1.
You know, if it's just simply but if it's power to it.
I'm gonna trust that the circuit is freaking with. There's another question. I'm being confident in myself.
I'm on 6.
You guys think for your best? You guys think for your best?
so confident in my check my answers.
Oh, wait, so you did it, you have to multiply calculator.
Wait, this is my count. Yeah, maybe I should chart this.
Alright, then you can multiply this.
Oh, we're in the wrong zone. 2 times the square root of x plus 1 over 2 times the square root of x plus 1. Sure, we're going to do this. It will be 2.
I see what you're saying.
I could charge my calculator on this. They're all green.
Yeah,
And then
so,
I take it out, and then I put that in the red.
You low-key don't need a calculator.
Oh wait, now they all just turned on.
Oh, really, Oliver?
So this is like the equivalent of 2x minus 3 to the power of 2/3. You have 3 right here. So you bring down the 2/3.
Go back in.
And then I know this one.
They're all
I don't think that.
Right now, 2/3.
I think it has a battery or something.
You got your chance, that's what.
I don't know.
Why did you do it like that?
I don't, it's, you could just put it there, I don't think it really matters.
Apartment number 24.
Yes.
Why does mine not have like the this?
Which one I get is
for the light?
what? Which one is
Oh, I can't tell if they're charging.
What was that?
You don't have to be right.
Yeah, I forgot we were.
Intersection.
I just have to find the slope. One week. Thank you,
How do you do the greater than or equal to thing again?
It was. Wait.
Who's the alpha down?
Oh, it was second, man.
Second one, yeah.
Where you go?
Yeah.
Has your done your timeline?
I was by myself, but yeah, I did my time one. Why?
So I have to finish it.
Do we have time to do it today?
Just do it at the end of class.
Okay.
Say to 16.
Okay, I've shared my answer to number 5 on the board.
4, 8, 12. 4 times 4 is 16.
Yep.
In the video, you solved this as 3.
Yeah, I factored it. I didn't check my factoring very well because it doesn't factor.
Okay, so
You actually have to do quadratic formula. Yeah. Here, I'll switch this over real quick so you can see. I'll leave that up for a minute so you can see.
You said it was 6.
Alright, you guys still have 25 minutes.
You were talking again?
I got square root of 16 over 3.
this is
Did you get no?
Got negative 3
Well, I
squared.
knew that it was negative 10, but the next one.
You can actually solve this problem.
Divided by negative 3.
Yeah, I did. So you did? Okay. I got you, but I did not differential or negative 10 things.
After all that.
That's so mean. Oh, yeah, moral of the story. Whatever, I didn't read space.
Me too. I was thinking about that when I walked to the bathroom. I was like, you know why I hate everything?
And
Because of all of these stupid
no one likes you, and also you're ugly. This isn't a very good moral. It's a, it's revolutionary.
You guys finished it?
Maybe the real moral of the story is the Pennsylvania you would be wrong.
Did you pay the 5.6?
Come back to haunt you.
What?
Because the answer is basically.
Oh, that looks pretty different.
I don't know what I'm looking. Oh, sorry. Kevin pointed out. Okay. 104 divided by 8. And then I subtracted the derivative. Yeah. And then I divide by 2. Oh, you just kept it like that. Alright. And then you have to simplify the 6th one. I see what you did. I just simplified it. Wait, yeah, I have
Okay, there is a thing.
How could you say something?
Oh, wait. I understand why this one, like, still works, is because even if, like, it's pure on the bottom, there still is a value of C that would work. Yes, but here it's stupid. It's not different.
There, if I 3 over 9 and then 3 over 6. That would be 1/3. And then that's the only thing.
He's not dead. Wait, that means this one is done, so I can just go back to what I was saying. No.
Okay.
Well, I got that one.
You need to do 3 times 1 and you will do that. Basically, you multiply both sides by 3 to get that to cancel. Then it'll be
What? What are you doing? Why would you change twice?
You just get 0 and 5.
Oh, it's in the power of 2 with me.
Yeah.
Wait, did I do that? I feel like it's...
Yeah, they want to do that one. They want to change to
Okay. We graph it.
It's a calculator, so any way you figure it
So
out.
when I'm graphing it, what about?
Have you done number 8? The answer?
Well, like, if I had the slope.
What is the answer?
One and 1x are two totally different things. How are you going to use the slope function to get an answer?
It's true. Is that graph?
So if you want to know when those two things are equal, you can graph them on their intersection.
Yeah, I did that in.
Okay. Which question you got? I'll figure out what's. What do you mean?
Hold on, Peter.
Oh wait, you know what? I bet you could.
GM 1 over negative 1/3 equals. No, 1 over negative 3.
Wait, I read
think I did that.
number.
Wait, this should be the difference.
So that, no.
Wait.
It's
Instantaneous.
How did I?
hit 3
I did something wrong.
or
Wait, we've been doing this wrong the whole time.
3 from this circuit. I've never done it
Yeah.
until now.
You got 2x minus. Okay, what's the
What is the
3
C?
almost squared, and then to the cube root. This
How do you
now
tell when
squared
it's
into the cube root. And now you can bring the power down. Lower the top by 1. Don't forget change.
That's what I'm saying. You just pay attention to class, don't be late. So that's why I didn't. Now that I have this.
What's on the spots?
Yeah, no, I just yeah. It's -7 over. I said -2.
Right here,
I don't know
I agree
how
with
that.
you. I mean, how do you get rid of the key
I
root?
don't know how you want it.
Yeah, your key root and your key root.
Let me see your work.
That is suddenly a big problem. That's right.
Again, I'm always happy to help, but just to be honest with you guys, almost all of the questions you guys are having are just either careless derivative mistakes or careless arithmetic mistakes with the slope formula, which is fine, but I'm just pointing out that that's an easy fix if you. It's an easier fix than having to relearn a bunch of stuff, I guess.
Yeah, I got it. I just didn't do I need to check our style.
Did you get 2.685 on?
No, it's 10 over 3. I was trying to search on my OCI. So, did you do chain rule?
The chain rule is more.
We used to everything.
No one's by one, isn't it?
Okay, I don't know. I'm just thinking of rules and that was like frustrated me. At first I was just getting like 5 or 0s. And then so people were like, no.
Okay, I shared my answer with number 6 on the board.
How'd you get that?
If that's not looking right, you need to tell me.
Why is that?
I haven't even finished.
Don't.
Because it's 2 squared vectors. You multiply it by that, you get 2x plus 10 over square root of 2. 2 squared vectors. You add the x, it's 3x.
Well, that's what I
It's 3x. Plus 10.
What have you done?
I think you did it right enough. This should just be. This is right, but you don't have that. That's not this. If you multiply that, if you multiply both of these by that, then it would cancel. It would cancel out on this one. So it's just 2.
How'd you get 3x plus 10?
So you have this, you multiply by
Both of them by the
yes.
multiply the one on the left by so they're
Well,
one term.
if you multiplying this, so then what's product? Is it you're multiplying it by this, so you're multiplying it by this, so then you get rid of this on the bottom. So you have
You just have 3x plus 10 period. Equals 0.
it's just that. So yeah, you do have that to the right, and that is just
Oh, I get it. I mean, what's the question? Derivative of the first thing times the second thing. Plus the derivative of the second thing times the first thing. Wait, is it the
It's Thursday. Oh, it's not like thinking so very fast. I always don't. Wait, I don't need a product quote. I was thinking about post over. Wait, question was the first, the top of the answers.
I got to solve it. I want to solve negative 3. Oh, you see 2/3 divided by 2.
Are we gonna try?
That equals, all that equals here.
Oh, Mr. Johnson, here's some really good news.
You finished question 7.
No, my hamster doesn't hate me.
Huh?
My hamster doesn't hate me.
Wednesday.
I mean, that's debatable.
At first I thought but I was like,
Oh.
I actually get Hey.
Oh, ready for you? One eye.
So 0.
I would from water. You didn't do it, bro. I'm waiting for you guys to get
You need to watch me do that.
I don't know what to do. Let me just
See what? Dude. What are we actually doing? What are we doing? What is sick? You need to watch better. I know it's rated really high, but like.
I think we're wearing the same jeans.
I'm gonna throw my calculator to you.
I think my jeans are a little bit longer.
My jeans.
Oh, you weren't talking to me.
Oh, oh, you thought y'all were matching jeans?
Huh? I thought that's what she was saying.
Oh no, we're
I don't think those jeans would look good on me.
Mr. Johnson, you need some barrel jeans. And you need to curl your hair. Get your nails done. You should get 28-inch extensions and have hair like this. And then you can put it in like a mouse tank and the mice can grab onto the hair and you can like swing them around.
I can't understand you once you start laughing. That sounds like, you know Halloween is over, right?
It's just like the new Mr. Johnson. You're gonna walk into class on Tuesday and you're gonna have like hair down to
Right now.
and like mice are gonna be eating the ends of it.
Yeah, have you ever seen the Undercover Boss show?
No.
Like people do like heavy cosmetics and then they like pretend to join the restaurant or whatever and see how their people work. I should do that and like I'll just be like a different person and I'll tell y'all I'm a sub and I'll just see like how y'all act when you think I'm not here.
I thought you were.
I saw the Star Wars one for that, but that's
But you should have like mice at the end of it. And have a little bowl of cheese and you can like feed it. You should get like a rat cage. So cool. So cool.
And then like when we were gone for 2 weeks on winter break.
I'll take them to different with my hamster. I'll like roll the cage around in the hole.
I think I'm gonna pass, but
You should get a goldfish.
no, I think I'm good. I would like some plants though. I need.
Do you want a plant? I'll bring you a plant.
I like plants, but I started like collecting plants in here at one point, and then COVID happened, and I had to go and bring them home, and then I just never brought any of them back. So
Miss Evans has plants. Ask her for mine.
people don't want to give up their plants.
No, like I literally.
Give me your hamsters.
No, okay, so Miss Evans
No.
doesn't have to. My hamster is gonna bite you. Like you need to feed it babies. That's the only reason why you do
I bet
this.
your hamster will like me more than he likes you.
But no, Miss Evans was like, Sophia, I'm gonna give you a propagation of my plant. She has a bunch of snake plants. You know, like the white ones that have.
Are you done with number 6 yet?
I'm getting there.
Okay.
No.
Let's do that.
It's still just equal x.
Get away from me.
So you would take the natural log of it.
I've never seen one.
Yeah, it's still equal to x. What do you also multiply by the?
All breaks on 8.
So Friendsgiving is we have Friendsgiving.
What?
You done 8?
Yeah.
I like that.
What?
Am I gonna
What's the answer to it?
No, which one is it?
Oh.
where should I bring? I can bring my hands.
Number
I'll bring my
8, it's the
hands.
top of
Do
the,
you wanna
like,
bring your
third
hamsters to
page.
my house?
Okay, yeah. Oh, what's the answer?
I've never seen your dog.
The answer,
Luna?
it was,
No. Is that not your dog's name?
I don't
Actually, no.
Was it not continuous?
yeah,
Are you sure?
yeah, I'm sure. I checked on Classroom.
It's non-differential. 7 is non-differential.
Mr. Townsend?
Yes.
So when this ends, I'm gonna head down to the advisory teacher and sign up for it, but I'm just gonna leave my stuff here. Come back.
Okay.
Is that Joe?
I'm sure you will come back for your MacBook.
I will come back for it. I don't wanna do it.
Are you on 7?
Oh, we've been on 8? Oh, not just on.
Route.
Oh, we don't have it.
Okay, so.
Are we gonna go to Tim's this year? Remember last year when Bert started telling us Jack or
I see what you did
But
for
then I really went to the pizza.
yes. I mean, so I did like this.
Double.
What?
I don't think you don't want I wouldn't either actually. That would like if you took my pizza ever. You? Wait, that like puts into perspective. Jeez. That's like tricky on my mind. Well, negative 12. Plus
This is
Wait, do I have it in here, Brian? Yeah, when I
Wait.
do that,
Shoot.
value put in 11 tabs. Oh my god.
Okay, I did.
I read 5.5 on the other.
Mr. Johnson. I have a question for you. Oh, I didn't see you like.
What?
If I have a
said it so
number
quiet. I just thought you were talking to yourself again.
No. Like, does this mean it does not apply?
3 does not equal 3,
3 does equal 3.
so that would mean it always applies if it was true.
But there's no variable. So there's no.
It'd be 2.
Or did I take the derivative wrong?
Well, this is an absolute value, so you really need to think about this graph to be careful there. What number is that?
I don't even know. I did it. What did you say?
Okay, where's it at on the
It's
page?
the back one. No. Second from the bottom. It's the far back.
Cause, yeah, it's.
Sophie, is your paper more green? Yeah.
Okay, here we are. Okay, so you know, oh, you can't see. If this was just 3x plus 6, that's mx plus b.
Yeah.
So y-intercept of 3 or 6, slope of 3. So it looks like this, right?
Yeah.
But because it's absolute value, it's always positive. So the stuff that's positive, you leave positive, and the stuff that was negative becomes positive.
I see. So does it?
So where?
But there's a cusp.
Yeah, but this cusp is at what x value?
Like 2.
2's over here.
-2 is like.
Okay, is -2 between A and B?
Yeah.
So it's not differentiable from -4 to 0?
So I got 7.
Yeah.
This is a cusp, so that means it's not differentiable. So, and it has to be differentiable from -4 to 0,
Since it's
non-inclusive. So, yeah, it's not differentiable there, so mean value theorem doesn't work.
Okay.
It could be true, but it's not guaranteed to be true.
Because I just like guesstimated on the.
Yeah, but this derivative though, you need to think of the graph so you can see the slopes. Alright guys, it is about that time to pack up. So again, originally I thought we would have enough time that I would only be asking you to do a couple pieces of homework. So this is in AB. Please go sit down. This is in AB, so this is the time you get extra time for your homework. Some weeks, you know, you've got to do Thursday night homework before Friday, but by Tuesday, you do not have to have this ready to turn in, but I will ask that you get at least through the first 10 questions. So that's probably pretty close to where you got. I hope that that's 1 or 2 less than what you got to, because I would like you to have to think about this again outside of class. I will give you a little bit more time when I see you on Tuesday to work on this and ask questions on this before I expect you to turn it in. But of course, it's certainly not going to hurt you to do it early. If you have nothing else going on during advisory, consider going past question 10. But at least to question 10, I have all the first 10 worked out as videos on the class website. So even if you get stuck, you've got resources to help you get unstuck.
I don't know where